Stages of sleep. Onset of sleep. Beta brainwaves are the small, fast brainwaves associated with alert wakefulness. Alpha brainwaves are the slightly larger and slower waves associated with relaxed wakefulness and drowsiness. Hypnagogic hallucinations are vivid sensory phenomena that can occur during the onset of sleep. One common hypnagogic hallucination, the vivid sensation of falling, is often accompanied by a myoclonic jerk or sleep start. On average, the progression through the first 4 stages of non-REM sleep takes about 50 to 70 minutes. Stage 1 of non-REM sleep begins when alpha brainwaves are replaced by even slower theta brainwaves. This stage lasts only a few minutes. Stage 2 non-REM sleep represents the onset of true sleep. It is defined by brief bursts of brain activity that last a second or two. These are called sleep spindles and K complexes, single but large high-voltage spikes of brain activity that occur periodically. Theta waves predominate, but delta waves begin to emerge. Stage 3 and Stage 4 of non-REM sleep, sometimes referred to as slow-wave sleep, are physiologically very similar. Delta waves represent an increasing portion of total brain activity, from 20% or more in Stage 3 to 50% or more in Stage 4. In Stage 4, the sleeper is virtually oblivious to the world. During REM or REM sleep, visual and motor neurons in the sleeper's brain activate repeatedly just as they do during wakefulness. The sleeper's eyes dart back and forth beneath closed eyelids. Rapid eye movements and voluntary muscle activity is suppressed. Heart rate, blood pressure, and respirations can fluctuate up and down, and muscles twitching occurs. Throughout the rest of the night, the sleeper cycles between non-REM and REM, with each cycle averaging about 90 minutes, varying from 70 to 120 minutes. Periods of REM sleep become longer, and less time is spent in non-REM. Yawning regulates and increases your level of arousal. Thinking about yawning may trigger the behavior, but yawning is not contagious. Prolonged wakefulness results in a sharp increase in adenosine levels and sleepiness. Slow-wave non-REM sleep produces adenosine levels. Caffeine blocks adenosine receptors, promoting wakefulness. Sleep paralysis is a temporary condition in which a person is unable to move upon awakening in the morning or during REM sleep. Deaf people who use sign language sometimes sleep sign during sleep. Sleep researchers have been unsuccessful in having extended dialogues with people who talk in their sleep. It is not dangerous to wake a sleepwalker, but it's difficult because sleepwalkers are in deep sleep. Sleepwalking may have a genetic component. Over the course of our lives, the quality and quantity of sleep change considerably. From birth onward, total sleep time, REM sleep, and non-REM sleep slowly decrease. The amount of time spent in slow-wave non-REM sleep, stages 3 and 4, also gradually decreases over the lifespan. Why do we sleep? A biological need for sleep is clearly demonstrated by sleep deprivation studies. After as little as one night's sleep deprivation, research participants develop microsleeps, episodes of sleep lasting only a few seconds that occur during wakefulness. Sleep researchers also study the effects of REM and non-REM deprivation. When people are selectively deprived of REM sleep, they experience REM rebound. When deprived of non-REM stages 3 and 4, they experience non-REM rebound. The restorative theory of sleep suggests that sleep promotes physiological processes that restore and rejuvenate the body and the mind. Non-REM sleep is important for restoring the body. REM sleep is thought to restore mental and brain functions. The adaptive theory of sleep, or evolutionary theory of sleep, suggests that sleep patterns evolved over time as a way of preventing a particular species from interacting with the environment when doing so is most hazardous. Dreams and mental activity during sleep. Sleep thinking takes place during non-REM sleep and consists of repetitive, bland, and uncreated ruminations about real-life events. A dream is a story-like episode of unfolding mental imagery during sleep. Sleep researcher J. Allen Hobson suggests that dreams have 5 basic characteristics. Emotions can be intense. Content and organization are usually illogical. Sensations are sometimes bizarre. Even bizarre details are uncritically accepted, and dream images are difficult to remember. Dreams occur during both non-REM and REM sleep, but dreams during REM are more frequent and of longer duration. The brain's activity during REM sleep is distinctly different from its activity during either wakefulness or slow-wave non-REM sleep. The primary visual cortex and the frontal lobes are essentially shut down during REM sleep. Thus, the sleeper is cut off from both information about the external world and from the brain centers most involved in rational thought. The amygdala and the hippocampus, structures in the limbic system that are involved in emotion, motivation, and memory, are highly active during REM sleep. Research suggests that REM sleep helps consolidate memories, especially procedural memories. REM sleep increases after learning a novel task, and deprivation of REM sleep following training disrupts learning. Brain activities activated during training on a particular task are reactivated during REM sleep. Thus, REM sleep may help stabilize the neural connections acquired through recent experience. Dream researcher Calvin Hall reported that a dream's themes often reflect the daily concerns of the dreamer. Certain themes, such as falling, being chased, or being attacked, are common across cultures. Environmental cues during dreaming can also influence dream content. Why don't we remember our dreams? One theory is that fundamental changes in brain chemistry and functioning that occur during sleep, such as frontal lobe inactivity and reduced neurotransmitter production, fail to support information processing and memory storage. We are much more likely to recall a dream if we wake up during it, if a dream is vivid, bizarre, or emotionally intense, and if distractions upon awakening do not interfere with our ability to recall it. It's difficult to remember any experience during sleep, not just dreams. A nightmare is a frightening or unpleasant anxiety dream that occurs during REM sleep. Sigmund Freud, founder of psychoanalysis, believed that dreams are manifestations of repressed urges and wishes. They serve as a safety valve for unconscious and unacceptable urges. Freud believed that dreams have 2 components: the manifest content, or the dream images themselves, and the latent content, the disguised psychological meaning of the dreams. While dreams may provide some information about psychological conflicts, research does not support Freud's ideas about dreams. The activation synthesis model of dreaming, proposed by J. Allen Hobson and Robert McCarley, maintains that dreaming is the brain synthesizing and integrating of memory fragments, emotions, and sensations that are internally triggered. This theory does not state that dreams are meaningless. Meaning is found by analyzing the way the dreamer makes sense of the chaotic dream images. At least some of our dreams mirror our real-life concerns and desires. The more bizarre aspects of dream sequences may be due to physiological changes in the brain during REM and non-REM sleep. Some argue that dreaming consciousness is no different from waking consciousness in its attempt to make sense of the information that is available to it, only the source of the information differs. Because dream interpretations occur when we are awake, perhaps conscious speculations about dreams reveal more about the psychological characteristics of the interpreter than about the dream itself.